So in this video, we're going to be using first principles in order to find the derivative of a few examples. So in this first example, we're going to be find from first principles f dash of x, where f of x is equal to 2x take x squared. Now, it's a good idea to always find f of x plus h. So f of x plus h, so essentially wherever we have x in this formula, we want to replace it with x plus h. So we're going to have two lots of x plus h, take x plus h, lots of x squared, because x squared, so it'll be x plus h squared. Now we can expand this, so it'll be 2 times x, which is 2x, 2 times h, which is 2h. Take x plus h all squared. Now this is a perfect square, so in order to expand a perfect square, we're going to do the first term all squared, so it'll be x squared, and then we're going to multiply these together and double it, so it'll be 2hx, and then we're going to square the last term, so it'll be plus h squared. And then one last expansion, because we want it all as single terms, so it'll be 2x plus 2h, and then it'll be minus all the things in the bracket. So it'll be minus x squared, take 2hx, take h squared. So now we've got our f of x plus h. So it's a good idea to memorize the first principles formula. So the first principles formula is that f dash of x, so the derivative function, is equal to the limit as h approaches 0 of f of x plus h, take f of x all over h. So substituting in what we've got, don't always remember to write the limit as h approaches 0. So our f of x plus h is this long bit here. So we're going to have 2x plus 2h take x squared, take 2hx, take h squared. Now we're going to be taking f of x, so it's a good idea to use brackets here because that way you won't mess up with the negatives. So we're taking f of x, which is 2x take x squared, all over h. So we've now got the limit as h approaches 0 of 2x plus 2h take x squared, take 2hx, take h squared, and then take 2x, and then negative x squared, so negative 1 times negative x squared will be positive x squared, all over h. Now, what we're going to be doing is we're first going to be cancelling any terms that cross out, so you notice that there should generally be some terms that'll cancel out. So we've got 2x, take 2x, so that'll cancel out. We've got, what else do we have? Minus x squared plus x squared, so minus x squared plus x squared will cancel out, and then we'll be left with these terms. So we'll have the limit as h approaches 0 of 2h take 2hx take h squared, all over h. So now what we want to do is, we can't divide by 0, remember? So we need to try and factorize this top line to take out a common factor of h, so then we can get the h's to cancel in the numerator and the denominator. So the limit as h approaches 0, so we're going to take out a common factor of h, so it'll be h times 2, and then if we take out a common factor of h, we'll have negative 2x, and we take out a common factor of h, we have negative h all over h. So as I said, the h's would cancel, because anything over anything is 1, well, generally, so h over h is just 1, so we can cancel that out. So we're going to have the limit as h approaches 0 of 2, take 2x, take h. So now we can actually, so what we can do now is, as h approaches 0, so that's going to effectively make this term here 0. So what we're going to be left with is 2 take 2x, because h has approached 0. So actually, so the derivative of 2x take x squared is 2 take 2x. Now, the next example I'm going to do is this one here. So, find from first principles the slope function of f of x, where f of x is equal to 3 over 1 take x. Now the slope function is just another way of saying the derivative. So first we want to find f of x plus h. And then, so wherever there's x, we're replacing it with x plus h. So we're going to have 3 over 1 take and x plus h. So we want to write that as 3 over 1 take x take h. So that's our f of x plus h. So from first principles, we're going to have f dash of x is equal to the limit as h approaches 0 of f of x plus h take f of x all over h. So now what we're going to do is we're going to substitute in our values. So the limit as h approaches 0, so our f of x plus h is 3 over 1 take x take h take 3 over 1 take x all over h. Now this looks quite nasty because there's a lot of fractions. Now we can simply remove these denominators. So we've essentially got a fraction divided by, we've got fraction divided by something else. This looks nasty, as I said, but we can simplify it. And the way we do this is we multiply this whole term. So we want to get rid of this numerator. So to get rid of this numerator, we need to times it by 1 take x take h. Okay, and to get rid of this denominator, we actually need to times it by 1 take x. Now, we can't just multiply something by something. It's going to change the meaning of it. But if we multiply it by 1 take x take h all over 1 take x, all we're doing is multiplying it by 1. So this isn't actually changing the meaning of this. So I'll show you what it looks like in the next step. So if we multiply this term by both these, what's going to happen is this and this will cancel out. So we'll be left with 3 lots of 1 take x, because this and this have cancelled out. And we'll be left with, on this, the 1 take x will cancel with this, so we'll be left with 3 lots of 1 take x take h. So that's removed. We've actually removed the numerator and the two denominators on this top line, However, because we're multiplying it by these terms on the bottom as well, we need to multiply h by this and by this. So on the bottom line, we're going to have h lots of 1 take x take h, 1 take x. So now we've removed the fractions. So what we're going to do is, when you get to this stage with fraction ones, leave the denominator. but we want to expand the numerator to see what we can get to cancel. So 3 times 1, so 3. 3 times minus x is minus 3x. Take 3. Take minus x, which is positive x. Positive 3x. Minus 3 times minus h, which is positive 3h. All over, and then just leave the denominator, so h, 1 take x, take h, 1 take x. So our next line, we are going to have the limit. So what do we notice from up here? What can we get to cancel? We've got positive 3 and negative 3, so they'll cancel. We've got negative 3x and positive 3x, so they'll cancel. So we're just going to be left with the limit as h approaches 0 of 3h all over h, 1 take x, take h, 1 take x. So the h's will cancel. And then we're left with the limit as h approaches 0 of 3 over 1 take x, take h, 1 take x. Now, now we want h to approach 0. Even though it's on the denominator, it's not by itself like it was in the past, so we can actually make h approach 0. So we're going to now have, so we're taking our limit as h approaches 0, so what we're going to be left with is 3 over, if h approaches 0, we're just going to be left with 1 take x and 1 take x, which we can simplify to being 3 over 1 take x all squared, because it's 1 take x times 1 take x. So we're going to, and hence find f dash of 2. So what this is meaning is this is our f dash of x, so we're going to find f dash of 2. And so wherever there is x in this function, we're going to be replacing it with 2. So it's going to be 3 over 1 take 2 all squared, which is just equal to 3 over 1 take 2 is negative 1 all squared, and negative 1 all squared is just 1, so it'll just be 3 over 1, which is just 3. So interpret part B. So what is it that we just calculated? So remember, the derivative function is, so interpreting part B, so the gradient of the tangent, of the function f of x, our original function was 3 over 1 take x. The gradient of the tangent of the function f of x equals 3 over 1 take x is 3 at the point x equals 2. Sorry, I just realized that the interpreting part didn't get caught in the camera. So the gradient of the tangent of the function f of x equals 3 over 1 take x is 3 at the point x equals 2.